Okay, we're on page 6 of the notes here. We're going to be looking at domain and range. Okay, the simple way to explain domain is it's the set of allowable x's, and the range is the set of allowable y's. If you want the more technical definition, domain is a set of all real numbers x for which the function is defined. The range is a set of all real numbers y given as x varies for which a function is defined. I just think domain allowable x's, range allowable y's. Now you can write the domain and the range in interval notation. Usually that's the way they request it, and I would actually say that to be the default because that's what's mentioned in the syllabus. You can also put it in inequality notation, which is more the approach they did in the old syllabus, but it's good to know both, so we're going to look at both notations. Domain and range can easily be seen if you've already got the graph of the function in front of you. So let's do some ones where we've already got the graph. So this says find the domain, find the range for each of the following. We're going to do it in both interval and inequality notation. Let's start off with inequality notation and interval after. So here, domain x values. So if you see that this is an arc of a circle, and if you pick any x value between -4 and 0, you'll be able to find a y value. So the domain is from -4 to 0, inclusive of -4 because it's a closed circle there, and inclusive of x is 0 because closed circle there. For the range, that's the allowable y values, or the y values that we see. The lowest height is 0 and the highest height is 4 inclusive, so it's between 0 to 4 inclusive. Now in interval notation you would write this as the domain is -4, 0, and because it's equal to close bracket, 0 to 4 because it's equal to close bracket, close bracket. Sometimes some people add for interval notation is that they note that the domain of the x's, so they write x and then they put this little e symbol, means it's an element of, and they would do that y is an element of, because there's nothing in here that suggests that you're talking about x's or y's. Okay, I think it's sufficient just to write down the braces and what's inside. That's enough. We know we're talking for I for domain and for I range. B. What's the domain here? Well, if you have a look, there are arrows. So this is all the x values, and we write that as all real x. For the range, the y value, well, there's only one y value that appears here, y equal 3. Okay, so it's not. That's how you would write it in that notation. In interval notation, we have a more numerical way of writing. So all real x is negative infinity, infinity, open bracket, because we could never get to infinity, and a range 3, 3 with close bracket. Occasionally you will see just close bracket and 3. Both are acceptable. Alright, next one, domain. Once again, there are arrows. So any x value you could select and you can get a y value, because the arrows say it keeps going in either direction. So that's all real x again. So an interval notation, open bracket, negative infinity, comma, infinity, close bracket. Next one, range. Okay, now this is an asymptote. We're approaching -2, but we'll never hit it. So we can't have an equal to. So it's going to be like that with no equal to. I'm going to put a y. Actually, well, that goes to infinity. So the way you would write that, erase that, is y is greater than -2. That's how you would write it in terms of an inequality. Any y value is possible that is greater than -2. You'd write a little bit different in interval notation because we actually put in the infinity here. The lowest possible y value we can have, well not included, is -2. So open bracket because not including -2, and we go all the way up to infinity, and another open bracket to close, curvy bracket to close, because we can never reach infinity. Alright, let's keep going. Next one, D. Domain, well, there is, looks like we can go any x value, we can get a function there, so it's all real x. The range, well, looks like we're asymptotic with 0 here, so it's between 0 and 4. Okay, so you'd write it like that. Inclusive of 4 because we hit 4 here. Not inclusive of 0 because the x-axis is an asymptote. Interval notation, negative infinity, infinity, open brackets. This one, 0, 4, closed for the 4, open for the 0. Okay, this one, domain, you can pick any x value. So once again, it's all real x. So negative infinity, infinity. Range, now the lowest value for y is negative 4, and then it's everything greater than that. So greater than or equal to negative 4. Y is greater than or equal to negative 4. In interval notation, negative 4 inclusive, all the way up to infinity, open bracket, to curly bracket to finish. Alright, so that's all and good when the function is drawn. When the function is given to you as an image, it's very easy to work out domain and range. What happens if you can't sketch? So firstly, if you can sketch, sketch. Okay, if you can't sketch, there are a couple of rules that can help you when you're finding domain and range, particularly domain. Range is very tricky without the sketch. First, for domain, you can't divide by 0. So if you got something like over x, x cannot be equal to 0, and that would form part of your domain. And also, we can't take square roots of negative numbers. So if you got a square root x, that restricts the domain to being x being greater than or equal to 0. So there's some big tips for working out the domain just from a rule. For range, square roots of real numbers are greater than or equal to 0. Any function, any real raised to an even power is greater than or equal to 0. Fractions can only equal to 0 if the numerator is 0. So if you've got something like 1 on x, there's no way that, or y equal 1 on x, there's no way that y can't equal to 0 because that fraction has a non-zero on the top. And if you've got an exponential here, a is just a number, raised to the power of x, that's always greater than 0. So that's a couple of things that can help you for range, but really ultimately the best way to work out range is if you can sketch the function, which usually you'll be able to sketch unless it's messy. Alright, let's do some questions. Find the domain and range for the following. And it says answer in interval notation. Okay. I reckon if we can sketch it, we're going to sketch it and it'll make life a lot easier. So first one I'm going to quickly sketch, right? We should recognize this, y equal mx plus b, straight line, y-intercept of 4, gradient of 2. It's going to look something like this. Okay. And it'll cross there at negative 2 if you work it out. So quite obviously the domain can be all real x. You can sub in any x you want and you'll work out a y value. And also this function extends to infinity in the y direction as well. So it says an interval notation, so let's go. So domain, x is going to go from negative infinity to infinity. The range is also the same, from negative infinity to infinity. Okay, next one. Here we see an f of x, just treat that as y. This is y equal x squared minus 4. So you should recognize that straight away as your basic parabola, shifted down 4. Okay, so something like that. Alright, you can work out these if you want. Your x-intercepts if you want. This, domain, negative infinity to infinity, any x value you can work out a y, there's no restriction there. Range, the lowest value is negative 4 for y, and that's included. And then we go all the way up to infinity, open bracket that. Okay. Next one, this one. if you know how to sketch this, this is a hyperbola, the basic hyperbola shifted 5 to the left. So it looks something like this. So if you sketch it, you can quickly work out what the domain and the range are. We might, so from that you can see that x can be anything except it can't be -5, where the denominator equals to 0. So the denominator can't equal to 0. So therefore x cannot equal -5. Now how do we do that? In terms of writing this in interval notation, well, it's two sections, it's here and here. So we can go -∞, comma, -5, not including -∞, not including -5, so it's curly for both, unioned with then starting from -5 and going to +∞. So that's the domain. The range, you can have any y value except for 0. Okay, the function doesn't cross the x-axis, so the range, we can go from -∞ up to 0, not including 0. So that's that bit, and then we've got this bit as well. So we're going to union that with 0 to infinity. Notice open brackets because we're not touching 0. Okay, that's that one done. Okay, next one. Alright, you should recognize this if you know your functions as a semicircle radius of 4, and it's the top part of a semicircle, so it should go up like that, center origin. It's very good seeing, if you can sketch, it makes domain and range so much easier. So domain, we're going from -4 to 4. Now it's inclusive. Okay, we can equal to -4 and 4. Range, the lowest y value is 0, and that's included. And the highest value is 4, and that's included. Okay. Alright. Next question. Okay, find the domain for the following functions. Domain, we only care about the x's. Alright, answer in inequality notation. Okay, this guy here, you might recognize that as, if you expand that, you got a -x², so it's going to be a sad face parabola. You might recognize that x-intercept set y equal to 0, so set this guy, which is y equal to 0, you get 0 and 6, and it's a sad face. So it looks something, oh, that's horrible. Should cross the origin. Looks something like that. But convince yourself that we only care about the domain. It's going to be, well, for inequality, you can't really, you just write all real x. Okay. Next one, it's square root, y equals square root 2x plus 5. Okay, so let's imagine we don't know what this looks like. What do we know? So the key thing for domain is that under square roots we can't be negative. So that means that 2x plus 5 has to be greater than or equal to 0. And if you solve this, you can quickly see you get this, and that's actually the domain. Okay, if you actually graph the function, it looks something like a parabola, half a parabola on the side. Okay, it looks kind of like this. Looks like that. Well, that's like a parabola on the side. Okay. Next. Okay, once again, very tough function to graph, but we can use our properties of domain. So first thing is that the denominator can't equal to 0. So convince yourself that x can't be 2, because if x is 2, that denominator is 0. And what else do we know? We know that what's under the square root has to be greater than or equal to 0. So that means x is greater than or equal to 2. But x can't equal to 2, so therefore I could have just dropped the equal to. X is greater than 2, and that's what is the domain for that question there. So you can see how denominators can't equal to 0 can help you work out a little bit of the domain, and under square roots under square roots have to be greater than or equal to 0. Alright, I'll quickly put up 3b because I'm running out of time. Pause it. There's the second bit. Pause it. answers